Hi everyone, in this video we are going to discuss the difference between type 1 and type 2 errors. When we do hypothesis testing, we have two cases. Either our null hypothesis is true or our null hypothesis is false in actual reality. But whenever we do hypothesis testing, we can either reject the null hypothesis or we cannot reject the null hypothesis. So type 1 error is the case when the hypothesis is true but we reject it. So basically we make an error that we reject the hypothesis, null hypothesis, when it was in fact true. So this is known as the type 1 error. The case when the hypothesis is true and we do not reject it is fine. So this is this case which is okay. Now the third case, when the hypothesis is false and we reject it, is again fine. So this has a term known as power, which is referred to as probability of rejecting the null hypothesis given hypothesis is false, and this is known as power. And lastly, when the hypothesis is false and we do not reject it, we call it as the type 2 error. So let's discuss the probability of type 1 errors, which is probability of rejecting when h0 is true, probability of type 2 error, which is probability of not rejecting when h0 is false, and power is probability of rejecting when h0 is false. So you can clearly see that probability of type 2 error is 1 minus power, because for the case when h0 is false, there are only two possible cases. Either we can reject it, which we call as power, or we can't reject it, which we call as type 2 error, and hence the probabilities should sum to 1. So we are given a significance level of alpha. So in that case, what would be the probability that we will reject the hypothesis given h0 is true? Let's say we have a distribution h0 when h0 is true with the mean mu naught, and let's say we observe a value, say x. With significant level alpha means that we will reject the value, any given value x, if it lies within z alpha. Z alpha is the value such the area, the shaded area is alpha, and corresponding value is z alpha. So if x lies within this shaded region, we will reject the null hypothesis, and probability of x being lying in the shaded region is alpha. So probability of type 1 error is alpha, is simply alpha is equal to significance value, and hence the probability for this case that not rejected, and when we assume that h0 is true, would be this area, which is simply 1 minus alpha. So this would be 1 minus alpha. Now to calculate the power or the type 2 error, we need to assume that h1 is true. We can't calculate the power or type 2 error by assuming h0 is true, because here in the conditional probability we have to assume that h0 is false. So let's see a small example of how to calculate power and probability of type 2 error. Now let's see a small example that how can we calculate probability of a type 2 error or power. So let's say we have a population, and null hypothesis is that the population mean is 30, but alternate hypothesis is that population mean is less than 30. And we know that we are given that the population variance is 10,000 and significance level is given to be 0.05. So let's say we collect a sample of 100 from population, and we have to calculate the probability of type 2 error. So probability of type 2 error is given by probability of not rejecting the null hypothesis when h0 is false. And let's say to calculate these kind of questions, we must know that if h0 is false, then what is true. And let's say get that we are given that the true value for the population mean is 26, because unless we know that if h0 is false, what is true, we can't calculate probability of type 2 error. So basically now we have to calculate that probability of not rejecting the null hypothesis when we know that the h0 is false and actual population mean is 26. So first we have to calculate that in what scenario would we not reject the null hypothesis. So in what case we won't reject h0. So let's say we started our hypothesis testing, we assumed that h0 is true, we calculated a sample, we collected a sample of 100, and we know that the sample mean will follow a distribution with mean 30 and a standard deviation of 10, which is root of 100. So we would know that the mean of the sample would be normally distributed with mean 30 and variance 100. Now we have to see that this is the step that we assume that h0 is true, and now we have to find the value for which we would reject null hypothesis, the values for which we would reject hypothesis and values for which we won't reject null hypothesis. So let's say we observed a value of x. We observed a value of x as our population mean. So in what case we will not reject it? So we will not reject it if x minus 30 by 10, which is that after normalizing whatever population mean we obtained, this value should lie in this region. If this value lies within this region, we won't reject it. Why won't we reject it? Because our alternate hypothesis is that our mean should be lesser than 30, and with the alpha value of 0.05, we get z alpha to be 1.64 for a normally distributed random variable. So if our g value lies in this region, we won't reject it. So this is the most tricky step for calculating probability of type 2 errors, that we have to find the values that, supposing h0 was true, what were the values that for which we won't reject the null hypothesis. So doing this calculation will give us x greater than 13.6. So these are the values for which we will not reject our null hypothesis. And now the next part is easier. So now we just have to simply calculate the probability of type 2 error, which is simply probability of not rejecting given the true mean is 26, and we have already calculated the values of the population mean for which we had not rejected the null hypothesis. And so we just want that the value is lying, the value that we get is greater than 13.6 given the true mean is 26, and which means that for a normal distribution we would like our value to be greater than 13.6 minus 26 divided by standard deviation, that is 10. That is, for a normal distributed random variable we would want our value to be greater than minus 1.24. so in this diagram we want our population mean value to lie in this region, and the area of this region is 0.29. so this is our probability of type 2 error. And now to calculate power, we simply subtract the probability of type 2 error from 1 and we calculate the power to be 0.11. So I hope this video has helped you to understand how to calculate probability of type 2 errors and power, because this is a bit tricky sometimes. And if you like the video, please feel free to share it with your friends, comment more suggestions, subscribe, and stay tuned as I'll be posting more good content. Thank you. Bye bye.